Hello, this is Kelly Gagnon, and we're working today on a related rates problem, and specifically an example that uses the angle of elevation. So the first thing I'm going to do is show you this graphic organizer. A graphic organizer is a guide for the problem, and it organizes the information for you in a visual manner. All related rate problems will follow all of these steps, so you can approach every related rates problem using this graphic organizer. The first example, you're going to write down the problem on the following slide, is this example right here. I will read it to you, but feel free to freeze or pause the video at this point and write down the problem, but I will read it to you and then we will complete the problem. A camera on the ground 200 meters away from a hot air balloon records the balloon rising into the sky at a constant rate of 10 meters per second. How fast is the camera's angle of elevation in degrees changing when the balloon is 150 meters in the air? Okay, so after we've written down the problem, the next thing we're going to do is we're going to draw and label a picture. So to label a picture, I need to think about where the camera is. So the camera is down here, and then I need to think about where the balloon is. So the balloon is up over here. Here's my balloon. Okay, so we're told from the problem that it's 200 meters away on the ground, 200 meters away on the ground. So we know that this is distance from here to here is going to be 200 meters. And we know this is going to form a right angle. And this is going to tell us, okay. So what else do we need to label in the picture? We have the camera, we have this. We want to know when the balloon is 150 meters in the air. So this is going to be 150. Okay, and we'll let that be our x value. And we don't know at this point what this value is right here. But it also says how fast is the camera's angle of elevation changing. So that means we're going to want to label theta to be our angle. Okay, so we're going to start off every related rates problem with drawing and labeling the picture. Okay, the next question we're asked to do is, what are you asked to find? When it says how fast it is, that's a rate of change. That means that's a derivative. How fast is the camera's angle of elevation changing? So that means we're being asked to find theta, d theta, and we're trying to find that with respect to time. So we're being asked to find d theta dt. And you might want to pay attention, it says it wants it in degrees. So you could just make a note to yourself in this box to make sure that when you're all done that your final answer is in degrees. Okay. The next stage in a related rates problem is to identify all the variables that you were given. And we need to go back to the problem to make sure we have that. We have some variables that remain constant. So we have a constant rate of change at 10 meters per second. And that's when it's rising. So that was our x variable is rising at a rate of change. So we're going to say that the dx dt is going to be at 10 meters per second. Okay, and it's also important to go, okay, well, what point in time are we talking about in this? We are talking about when it's 150 meters in the air. So when x is equal to 150 meters is what we're looking at. Okay. Now I'm also going to take a chance take an opportunity at this point, because now if we go back to our right triangle that we had, we did know that this length is 150 and that this length is 200. Okay, we said we didn't know what y is, but we can find that using the Pythagorean theorem. Okay, so the Pythagorean theorem, I'm just going to do the calculation for that really quickly. I can say that 150 squared plus 200 squared is equal to y squared. Okay, so that gives us that 62,500. If I take 150 squared plus 200 squared, it gives me 62,500 equals y squared. So that gives me that y is equal to plus or minus 250, but in this case the negative 250 doesn't make sense. So we can know that at this particular point in time that the y is going to be 250. Okay, that's just going to come in helpful to us down the road. So it's a calculation that we'll need later in the problem. Okay, so now we move on to the next part. We've gone through, we've drawn the, labeled the picture. We want to know what we're asked to find. We've identified the variables, and we've picked out some important information in time. And the next thing we're going to do now is we're going to write an equation that involves this formula, this triangle over here. So like it says, we're going to, the equation may be a geometric formula or a trigonometric equation. And this is going to be a trigonometric equation. And it says, do not include any point in time information. So we cannot include the 150 or the 250 in our problem. So that means we can include the 200, okay? And we can include the x, or we can include the y. So my equation right here, I know that y over here eventually is going to be 250. I'm not going to include that information right now. So I'm going to look for a trigonometric formula that uses x and the 200, and that's tangent. So I'm going to state that the tangent of the tangent of theta, here's my angle right here, my tangent of the theta is equal to, opposite over adjacent, is equal to x over 200, okay? So in this stage, it's really important that you do not substitute in the point in time variables, because when you go to take the derivative, they're all going to be constants and you can't take the derivative. You need to have the variables because we're going to need to do implicit differentiation. Okay, so the next step for us is after we have this equation, now we want to differentiate it. Okay, so we have the equation, and we want to take the derivative of both sides using implicit differentiation. And remember, when you take implicit differentiation, you need to be careful with the variables that you differentiate with. Okay, so the derivative of tangent is secant squared. Okay, so if I take the derivative of tangent, I get secant squared. If I take the derivative of x, I just get dx over t. Oh, over here, remember when you took the derivative of secant squared, you got to take d theta dt for implicit differentiation. And then the 1 over 200 comes out, derivative of x is 1, but I've got dx dt. Okay, and I just want to make sure everyone knows the derivative of tangent is secant squared. That's how I went from this step to here. All right, and the next step, we're going to go to... Okay, so the next step is that dx dt, we know that from above was 10. So we're going to substitute 10 in for dx dt. Okay, then we're going to simplify the fraction. 10 divided by 200 gives me 1 over 20. And the next step, I'm going to divide both sides by the secant squared of x. Okay, if I divide both sides right here, this step I'm going to divide by secant squared of x, because I'm trying to find, and we have to think about, why did I divide by secant squared of x? Because my whole goal in this problem is to find d theta dt. So there's d theta dt. I have it isolated all by itself right now. I have d theta dt equals this value. Okay, so in the next step, now what we need to do is we now need to know, we know what d theta dt is, but we need to substitute a value in for secant squared of theta. Okay, if we substitute a value in for secant squared of theta, we're going to go, so this is where we have to go back to our picture. Our picture at the beginning said that this length was 150, said that this length was 200. Here is theta, and here is 250. I can figure out what the secant of theta is. I know that the secant of theta is hypotenuse over adjacent. So here's my angle. My hypotenuse is right here, and my adjacent side is here. So I'm going to say that it's 250 over 200. So 25 divided by 20 then, the secant of theta simplifies to 5 over 4. So now I can replace this value right here of secant squared as 5 over 4. Okay, so when I go to do that, I'm going to say that d theta dt is equal to 1 over 20 times 1 over, okay, secant squared I know is now 5/4 squared, so that's going to give me 25 over 16. When I get the reciprocal of that, I'm going to get 1 over 20 times 16 over 25. Okay. When I simplify that for a decimal, I'm going to get 0.032. But this is in radians because over here we're in radians. We are not in degrees. So this is in radians per second. Okay. And we know that the problem asked us to do the problem in degrees. So I'm almost on the final step of this problem. If we go back and we say, okay, we wanted it in degrees and we state our final solution, I need to take, so I'm just going to do that conversion really quick, 0.032 radians. I'm going to multiply by radians to degrees. So I know that there are pi radians and 180 degrees. So I need to multiply my answer of 0.032 by 180 and then divide it by pi. And when I do that, I get 1.833 degrees. And so you would want to finish the final step of a related rates problem by stating what your solution is in a formal sentence.